So today we will be discussing the interfacing of the input devices. Of course, the instruction which will be used for getting the data or the information from the input device is the in instruction. And this in instruction is a 2-byte instruction, in and the port address. So very much similar to the output devices. Whenever it is required, we used to use out instruction. So the correct format of using the in instruction is in 8-bit address. And this 8-bit address is the port address of the input device at which it is being connected. So whenever we provide this instruction in 8-bit, that is in, suppose the address is 34. So it means 34 is the address, 8-bit address of the port where the input device is connected. So what it will do, it will copy the content of the input device into the accumulator. So whenever the microprocessor is going to execute in instruction, it will first read the machine code or the hex code of the in instruction. So first machine cycle will be elapsed in fetching and executing the hex code of in instruction. And the second machine cycle will be used for fetching the port address, that is the 8-bit number. So it means 2 machine cycle will be used for fetching the instruction and executing the instruction in 8-bit. But that is not all, because 2 machine cycle will be elapsed in fetching and executing the instruction. And then what it has to do, the purpose of using in instruction is to copy the data from the input device to the accumulator. So it will be using 3rd machine cycle. And in this 3rd machine cycle, the control signal will be generated, that is the read signal. And the data will be flowing from the input device through the data bus to the accumulator or to the microprocessor. So it means we are in requirement of 3 important things. One is the control signal, that is input output read signal. Second important thing is the buffers which will be used for the interfacing the port in case of input devices. And third will be the data which will be coming from the input device to be loaded into the microprocessor. So here the input device which is used to interface, we have already discussed the interfacing of the output device. We will be doing in a very similar fashion. We will be interfacing the input devices. In case of output devices, we were using latches for latching the information. But in case of interfacing input devices, we will be using buffers. In case of output device interfacing, the microprocessor is generating input output write signal. In case of interfacing of the input devices, instead of input output write, the microprocessor will generate input output read signal. And the rest of the process will remain as it is, as we have seen in case of output device interfacing. So here we are interfacing an input device which is actually a DIP switch. 8 DIP switches are being connected with that particular circuit. And this circuit includes the first of all 74LS138, that is the decoder circuit. Another circuit which is being used in this device, in this circuit, is the 74LS244, that is the octal buffer. And these octal buffer will be used to interface the switches to the data bus, meaning thereby whenever this information which is coming from these switches from S0 to S7, it will be transferred to the data bus. Of course, before it is going to transfer the data bus, it is necessary that this device must be activated. And this device can be activated if this signal is low. Output enable as well as this enable of the buffer can be done only when the input output select signal is low. Input output select signal can be low if we are going to assert low input output read signal as well as low input output address signal. So these signals means the control signal and the address is going to select the particular buffer. And once this buffer is activated, enabled, then only the information which is available on these switches can be transferred to D0 to D7. So let us analyze this particular circuit, that what will be the address of this particular buffer, how it is being coded so that a particular buffer which is connected with this switches can be able to place the data on the D0 to D7 bus. Now, here you can see in this 3 to 8 decoder, O4 output line of the decoder is going to generate the input output address, and input output memory and the read signal in combination is going to generate input output write low signal. Both the signals are low, then only this input output select pulse will be generated, which is in low, and this select pulse is going to enable the output, that is output enable, as well as going to enable the buffer also, and then only the values which are available, that is 0 0 0 1 1 1 1 1 will be available on the data bus, and through the data bus it will be coming to the accumulator, means it will be coming through the data bus to the microprocessor. So let us analyze that what will be the address which will be IO address through which the select pulse is going to generate. So let us analyze this particular circuit. We have A0, A1 and A2, which is the input line of the 3 to 8 decoder. A5 is connected with the enable line 1. A6 is connected with the enable line E2, and A7 is connected with the enable line E3. And we are not using A3 and A4 and keeping this A3 and A4 in the don't care condition. So if they are in the don't care condition, we can consider that these two signals are 0 and 0. So for the selection, for enabling this 3 to 8 decoder, it is necessary that A7 should be 1. For enabling E2, A6 should be 0. A5 should be 0. So means A7 should be 0, A6 should be 0, and A5 should be 0. A7 should be 1, A6 0, A5 0. And since A3 and A4 is not being used, so considering these also as 0. So A7 1, 6 1, 6 0, 5 0, 4 0, 3 0. Now let us discuss the condition of what will be the value of A0 to A2, because A4 is O4 is output O4 is connected with the NAND gate. So here, since we are considering O4, so O4 actually means 1, 0 and 0. 1, 0 and 0. This value will be available if 1, 0 and 0 will be there, then only this is going to generate a lower pulse. So 1, 0, 0, A3 0, A4 0, 1, 0, 0. So it means it is comprising the address 84. It means 84 is the address of this particular latch, of this particular interfacing device at which this input device is being connected. So whenever we want to take the information from these devices, we have to activate this particular buffer by providing the address 84. Why it is 84? This I have already explained, because A7 is 1 and A2 is 1 and the rest of the values are 0. So naturally the address will be 84. So in that particular case, we will be providing an instruction in 84. So in 84, what it will do, in is the instruction opcode, And this opcode, whenever it is executed by the microprocessor, it will came to know that it is a 2-byte instruction. So second byte will be fetched and executed, by which it will be able to know that 84 is the port address which it has to read. And in the third machine cycle, what will happen? This input output write signal will be input output read signal will be asserted. Along with this signal, this is going to give a low signal on the input output select. And whenever this input output select will go low, output will be enabled, buffer will be enabled, and whatever is the value F0 to S7, that is 000111111, it will be placed in the date on the data bus, and through the data bus it will be coming to the microprocessor. So this is the way how it can be done, the interfacing of the input circuit, input devices. Now, interfacing of input devices, as I told you earlier also, it can be done in the very similar fashion as we used to do the output devices. Only difference which lies that instead of using a circuit that is called latch in case of output device, we will be using buffer in case of input device. Instead of generating input output write signal in case of output device, we will be generating input output read signal by the microprocessor. This is the only difference. Rest of the things remains as it is same. So this interfacing circuit is going to generate an address, and the address value will be A7 to A0. A7 is kept 1 because A7 is to be 1 because A3 has to be enabled. A6, A5, and A4 is 0. A6, A5 is 0. A4 and A3 is in the don't care condition. So A4 and A3 is also 0. But since A2, A1, A0, now different values of A0 and A1, A2 can be used. But since O4 is connected, so O4 is going to signify 1, 0, 0 to that address, because the first value will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and fifth value, that is O4, because O0 will be signifying 0, 0, 0, O1 will be signifying 0, 0, 1, O2 will be signifying 0, 1, 0, O3 will be signifying 0, 1, 1, and O4 will be signifying 1, 0, 0. So that is why the address is 1, 0, 0. So it means the address of the input port will be 84. Now the control signal, that is the input output read signal, is generated. And why it is generated? It is generated for ANDing by ANDing the input output memory signal and the read signal. And since this has to be generated, so read signal is low, so here it will be high, 1. Input output is high, so inverter has been placed here, so that here it will be 1. So 1, 1, and it is an AND gate and NAND gate, so resultant will be 0. So it means input output read signal will be 0. And when this input output read signal as well as this address signal will be coming over here, it is again ANDed and with the it is ANDed with the output of the decoder circuit, and then the IO ADR, that is input output address and input output read, is being ANDed together to generate the input output select pulse. And this input output select pulse, once it is generated, it is going to enable the tri-state buffer, and the logic level of the switches, whatever is the position, it will be placed on the data bus. Now in 8085, 8085 is going to begin to read the switches from S0 to S7 during the third T state, of the third machine cycle, and places the result on the data bus, and through the data bus in the same time period, in the same T state, it will be loaded into the accumulator. Now when the switch is closed, it has a logic 0. When switch is open, it is on the logic of 1. So it means when it is open, it is representing plus 5 volt. When it is closed, it is representing 0 volt. So the actual value of this data, which will be copied into the accumulator through these switches, is 11111, where this is D0 and this is D1, D7. So the value is F and 8. So F8 is being transferred from this switch to the data bus, and through the data bus, the F8 will be copied into the accumulator. Now the multiple port address. Since what we have done, we have not used A4 and A3 in this decoder circuit. So the logic level of these lines can be either 00, it may be 01, it may be 10, it may be 11. So since we are not considering it, therefore this input particular port can be addressed, because since we are not considering A3 and A4, and the A3 and A4 could have any value. It may be 00, it may be 01, it may be 10, and it may be 11. So you can say that this particular interfacing circuit can be addressed by 4 addresses. It may be possible that it will be 00, it may be possible that it is 01, it may be possible that it is 10, and it may be possible that it is 11. So in the first case, the address will be 84. In the second case, the address may be 8C. The third case, the address may be 94. In the fourth case, the address may be 9C. So you can say that in this don't care condition, A3 and A4 can have any value, and depending upon A3 and A4 can have any values, we can get multiple port addresses of the devices. So either we put 84 along with the in instruction, the same port will be accessed, or we put 8C, the same address, the same device will be accessed. Similarly, if we put 94, the same device will be accessed, and if we put 9C, the same device will be accessed. So because of this interfacing condition. Otherwise, if we put A3 and A4 over here and it connect with the AND gate or NAND gate through A5, A6 and connected with the E1, E2, then it means it is fixed. But since it is in the don't care condition, we can have the multiple addresses of the multiple port address of the same device, same interfacing circuit. So the instruction which can be used to read this particular input port, it may be in 84, or it may be, just wait, or it may be in 8C, or it may be 94 or 9C. Any address can be given, and if this address is being given, any one of this, it is going to read the same port. So to read the data from the input port, the in instruction can be used, and when this instruction is going to be executed, and when this instruction is going to be executed by the microprocessor, during the third machine cycle, 8085 is being loaded by a value that is known as uh, uh, that is 8 F8 into the accumulator. So during the third machine cycle, 8085 is going to place the address 84 or 8C or 94 or 9C, whatever address is given on the lower address data bus, lower order bus, and then it is going to assert the read control signal, and then it is going to read the switches position. And whatever is the position of the switches, depending upon the value of the switches, because these 3 switches are closed, so it is 000. These 5 switches are open, so it is 111. So it is going to read the data that is F and 8 into the accumulator. So this is how the input devices are being interfaced. So all these interfacing which are discussed right now, these are the interfacing which is if the microprocessor has connected, if the peripheral devices are connected with the microprocessor in a peripheral mode, peripheral mapped input output mode. But if it is memory mapped input output, then the situation will be different. And the situation will be that in case of memory mapped input output, all the input and the output devices are identified as well as assigned the same address which is used to assign the address of the individual registers of the memory. So input output devices are considered to be like a register of the memory, either for reading purpose or for the writing purpose. One more important thing, that in case of input output mapped input output, we are using 8-bit address for accessing the input output devices. But since we are using 16-bit address for while accessing the memory, so 16-bit address will be used for accessing the input output device. Another change will be in case of input output mapped input output, we are using in instruction for reading the data from the input device, out instruction for displaying or giving the result to the output device. But in case of memory mapped input output, in which the peripheral devices are considered to be a type of memory, so all the instructions which are used for transferring the data from the microprocessor to the memory will be used for transferring the data from the microprocessor to the input output devices, or receiving the data from the input output devices to the microprocessor. So all the memory related instructions such as LDA or STA will be used instead of in instruction and the out instruction. It means if the peripheral devices are connected in a memory mapped input output, then it means there is no use of in instruction and out instruction, and all the memory related instructions will be used for transferring of the data of the either side. As you know that LDA instruction is a load accumulator, it will be loading the content of memory into the accumulator. Similarly, STA is a kind of instruction which will be storing the content of accumulator into the memory. Similarly, LDA will be used to load the content of the input device into the accumulator, and STA will be used to store the content of accumulator into the output device. One more change will be there in case of peripheral mapped input output. We used to generate the control signal, that is input output read signal and input output write signal. But in case of memory mapped input output, what we have to do, we have to generate memory read signal as well as the memory write signal. So all the operations which are used to do the interfacing of the input output devices with the microprocessor, if it is in the peripheral mode input output, that will be 8-bit address, separate instructions as in and out, as well as separate control lines, control signals are generated input output read or input output write. But when it is memory mapped input output technique, we will be using 16-bit address. We will be using all the instructions which are related with the memory, that is LDA or STA, as well as we will be using, instead of input output read and input output write control signal, we will be using memory read and memory write control signals.